This is Al Wolmer, and today's video is going to describe how to teach curve sketching in calculus using the Smartboard interactive whiteboard. On this first page, you see we have two tables with cell shades. These are features of Smart Notebook, and we're going to use these tables with cell shades to both engage our students as well as to organize the work involved in this process. Before we go on, we're going to switch from full page view to page width view and scroll down to see this table. And here we're eliciting information from our students. We're engaging them and asking them, what can we glean from a function, its first and second derivatives? And when we get the answer, we'll reveal the cell. So in terms of the function itself, we can find where the x and y intercepts are and where the horizontal and vertical asymptotes are. From the first derivative, our students should be able to tell us so we can find the critical points and the regions of increase and decrease. And from the second derivative, our students should be able to tell us that we can find the second critical points, which is where the second derivative is either 0 or undefined, as well as the regions of upward and downward concavity. I want to stress that we don't reveal these cells until our students have given us the answers. This is a means of engaging them and leading them through the process. Curve sketching can be a daunting challenge for students in that they feel that there is no limit to the way that a function can appear or the graph of a function can appear. But in fact, as we can show, other than at the critical points, really there are only 4 ways that the graph of a function can look, and that depends upon the first and the second derivatives. And so here we're using a table with cell shades again to reveal and to organize the answers. So we ask our students, what does first derivative less than 0 mean? And they should be able to tell us that that means it's a decreasing function. All right, what does a second derivative less than 0 mean? They should be able to tell us that that means the graph is concave down. So then we ask them, what does a decreasing concave down function look like? And we ask them to wave their hands in the air, and they should be able to do that. And when they've done that correctly, we reveal that this is what that function should look like. Similarly, for an increasing concave down function, a decreasing concave up function, and an increasing concave up function. This bounds the problem for our students in that really the graph of a function can only look one of these 4 ways. On the next page, we're going to organize the steps to get all the information we need. And similar to the first page, we're going to reveal these cells only when we have been able to get the answers from our students. So here I'm going to go back to full page view so we see the entire table. And these are all the things we need to find, intercepts, asymptotes, etc. So we ask our student, how do I find the x-intercepts of a function? When they've told us that we solve the equation f of x equals 0, then we reveal. How do we find the y-intercepts? We evaluate f of 0. And similarly for the asymptotes, the critical points, regions of increase or decrease, second critical points, and regions of upward and downward concavity. We then take these steps and we apply them to a function, and we find all of these pieces of data. We're going to skip all those steps and go to the final slide. Here we found that the intercepts are at x equal plus or minus 3. Here the y-intercept, the vertical and horizontal asymptotes, the regions of increase and decrease, and the regions of upward and downward concavity. We've drawn a set of x and y axes. We've drawn the vertical asymptotes. We've drawn the horizontal asymptote. And we've drawn the y and x intercepts. And now we ask our students again, in this region here, what does the graph look like? Well, they're able to tell us that this is a decreasing concave down function. When they do that, I'll reveal that, and so it's going to look like that. Here, it's going to be decreasing concave up. Here, it's going to be increasing concave up. And here, it's going to be increasing concave down. So this is what the graph is going to look like in these regions, constrained by the asymptotes and the intercepts. Then I ask a student to come to the board. Can you sketch this function? And we'll give them a pen and typically red ink, and we'll ask them to do that. Function that looks like that, bounded by that asymptote and that asymptote, going through that intercept. Fairly easy for them to sketch it like that. And similar in the other regions, they're able to sketch like this and like this. At this point, we engage the remainder of the class, see if they agree with what the student has done. Typically they will, and at that point I'll ask the student to simply tap the blue field once, and when they do that, a computer-generated graph of the function appears from behind. And they can see at this point how fairly accurately they have sketched the graph of this function without ever once evaluating the function and plotting points. This is Al Wolmer, and please visit my website to see more, alwolmer.wix.com/smarttraining.